Okay, in section 7.5, we're talking about the inverse circular function. So that means we're going to be looking at the sine, cosine, and tangent, but instead of putting angles in and getting ratios out, we are instead going to be putting in the ratio and getting the angle out. So it's the inverse trig functions that we're going to be working with, and we're going to be restricting them in the same way that our calculator does. All right, so if we look at the inverse sine function, so here is a sine function, and what we have to do is we have to restrict the domain for our sine from negative pi over 2 to pi over 2. Now this is an xy coordinate plane, and we're graphing it on an xy coordinate plane. We're not looking at the unit circle, but you have to think about then relating this to the unit circle. We're restricting it from negative pi over 2 to positive pi over 2. So we would be in the fourth and first quadrants if we're thinking about a unit circle. Okay. Now remember too that the outputs from sine and cosine, or the range, is always from -1 to 1. All right, so we restrict it in this manner because when we take the inverse of this, and so if we kind of like put in our identity line, remember when we do the inverse, it flips across the identity line. So the inverse y equals inverse sine of x would be here, would be the red curve that we're showing. And you can see why then it's important that we restricted it, because now instead of this thing oscillating about the x-axis, this inverse is going to oscillate about the y-axis. And if we went any further than what our restriction is, then this thing would be oscillating back and forth and the vertical line test would fail. So this is why we have to restrict it to just originally from negative pi over 2 to pi over 2, that would have been the domain, but now we're doing the inverse. So they flip-flop. So the range, or the output from the inverse sine, remember the output is the angle, so the angle output from the inverse sine has to be limited to negative pi over 2 to pi over 2. And the domain, the domain or the ratios that we're putting into this thing have to be from -1 to 1. So we're going in reverse here. Instead of putting in the angle and getting out the ratio, we're doing the inverse. We're putting the ratio in and getting out the angle. The angle is limited to negative pi over 2 to pi over 2. So that would be angles in the fourth and in the first quadrants on the unit circle. Okay. And you can see that sort of on your notes. They're asking for the domains and the ranges for these things. And so when you ask your calculator to do an inverse sine, it's going to give us angles only in those ranges. All right, so let's do some calculations with our inverse sine. Remember, we should be thinking of this inverse sine of x as some angle measure, and it is going to be limited to between the values of negative pi over 2 to pi over 2. So that's quadrants 4 and 1. All right, let's try a problem. Number 1, find the inverse sine of 1/2. Remember that the sine is y over r. And so we could draw a little picture. Now, thinking about which quadrants, normally we would look at this and we might think, oh, it's positive in the first and second quadrants. However, we know we cannot be in the second quadrant. We limit it so that this is a true function. We limit it to the fourth and first quadrant. So since this ratio 1/2 is positive, we know we're in quadrant 1. So draw a picture and a triangle and label it if you need to, but this is y over r. So this gives us a reference angle of pi over 6. And of course, we're in the first quadrant, so it is just pi over 6. Number 2, we're looking for the inverse sine of -2. And of course, this does not exist. The ratios that come out of sine and cosine cannot be smaller than -1, nor can they be bigger than +1. So this is asking us an impossibility. There is no ratio that would come out of a sine of -2, so we could not put -2 into the inverse sine. All right, number 3, this is a composition of sort of functions. Now, this arc sine is really just the same as inverse sine. It's sort of a more of an old-fashioned way of writing it, but arc sine and the inverse of sine are the same thing. So we're asking you to find the sine of the arc sine of -1/2, or the sine of the inverse sine of -1/2. So work on the inside first. What is the inverse sine of -1/2? In this case, the ratio 1/2 is negative, so we know we're in the 4th quadrant. And if you draw a little picture down there, you'll see that it is the arc sine of -1/2 is just negative pi over 6. And so what is the sine of negative pi over 6? Well, that's just -1/2. It's not all, when we do these composition functions, it's not always going to give us the same ratio as we started with. We'll see in this one that it doesn't work that way. So if we have the inverse sine of the sine of -4 pi over 3, now we don't have to restrict this because it's just sine. We can put anything we want into sine. So we don't have to limit the first thing. So what is the sine of -4 pi over 3? So -4 pi over 3 is in the 2nd quadrant. It's really the same as 2 pi over 3. And so the sine of 2 pi over 3 is the square root of 3 over 2. And so now we would just want to find the inverse sine of the square root of 3 over 2. And of course, we know that's positive, so it's going to be in the 1st quadrant this time. And so that would just be our reference angle of pi over 3, which would actually be pi over 3 because we're in the 1st quadrant. It is a positive. You know, that square root of 3 over 2 was positive. That forces us to be in the 1st quadrant. If it's negative, we would be in the 4th quadrant. Okay, so now let's move on to cosine. Let's assume we're going to restrict cosine in the same way we restricted sine, and let's see what happens. So we would, now this is not how we do it, but I want to show you why this would be bad if we did it the same way. So if we restricted the cosine from negative pi over 2 to pi over 2, then if we wanted to find its inverse, and we draw in the identity line and we flip it across the identity line, and this would be the inverse cosine. Well, you can see very clearly that this is no longer a function. The vertical line test would fail here, so we cannot restrict inverse cosine from negative pi over 2 to pi over 2. It doesn't work for cosine. And so what we have to do instead is we restrict it from 0 to pi. And by doing that, again, it's like this one of these one-to-one functions that we talked about back when we did inverse functions. And so when we get the inverse of that, we flip it across the identity line, and now you can see the vertical line test does not fail because we've restricted it from 0 to pi in the range, I guess, because now it's the inverse cosine. Okay. So this is the domain is going to be from -1 to 1 now. And the range is from 0 to pi. So when we get an angle out of inverse cosine, it has to be limited to the 1st and 2nd quadrants. And basically, because in one of those quadrants it's positive, and in one of the quadrants it's negative. So we'll figure out which quadrant it is based on whether it's positive or negative. All right. So again, we're going to put the ratio in and get the angle out for inverse cosine. All right, and so let's use this for some calculation. Remember, inverse cosine simply represents an angle, and that angle must be in the interval of 0 to pi, to 1 pi. All right, let's find the arc cosine. Remember, that's the same as the inverse cosine of 1/2. So it's positive, so we know we're in the 1st quadrant. All right, so that would simply be pi over 3, or 60 degrees. All right, example 6. Find the inverse cosine of negative square root of 2 over 2. So draw a picture. So this is negative, so we know that because it's negative, we are in the 2nd quadrant, because we're only in, for inverse cosines, we're only in the 1st and 2nd quadrants, 0 all the way over to pi. All right, so that is, if we we know we're in the second quadrant. We know we're going to have a 45 degree right triangle. And so that angle is 3 pi over 4. All right, let's do a composition now. So the cosine of the inverse cosine of negative square root of 3 over 2. Think about which quadrant we're in and what the angle has to be. So concentrate on the inverse cosine of negative square root of 3 over 2. So that means we are in the second quadrant. Square root of 3 over 2, that gives us a reference angle of 30 degrees. So we should be at something like 5 pi over 6. And so basically we're looking for the cosine of 5 pi over 6. And that indeed is negative square root of 3 over 2. But again, you're not always going to end with the same thing you started with this composition. So now let's look at inverse cosine of the cosine of 5/3. So again, 5/3 can be anywhere. That angle can be anywhere because the cosine is not restricted. We can put any angle we want into cosine. It's simply the angles we get out of the inverses that get restricted. So cosine of 5 pi over 3. Think about where that is. That seems to be in the fourth quadrant with reference angle of pi over 6 or pi over 3 or 60 degrees. And so the cosine should be positive 1/2. And so we have the inverse cosine of 1/2 and the inverse cosine of 1/2. And again, now we have to think, okay, that's 1/2 is positive. Even though we know 5 pi over 3 is in the fourth quadrant, we cannot do an inverse cosine in the fourth quadrant. We have to get an angle in the first quadrant because that's where we're positive in our inverse cosines. So we're pi over 3. All right, so now I'm going to sort of try, we haven't graphed any of these tangent functions, but I'm just going to show it to you and kind of demonstrate why we do it the same way here. We're going back, and this restriction for the tangent or inverse tangent is going to be similar to sine. Notice we have asymptotes at negative pi over 2 and pi over 2. So tangent never takes on, you can never put in an angle value of negative pi over 2 to pi over 2. But we are going to restrict it in just that range. That way, when we rotate it using our identity line, you can see that if we limit ourselves to just one piece of that trig, of that tangent function, then we will have truly a function for the inverse, and we won't have a vertical line test failure. So the domain is going to be any real number you can put in, right? The tangent of an angle could result in any value, big or small. So in this case, it's the inverse, so the domain is all real numbers. Now the range is similar to the inverse sine, but it's non-inclusive of that negative pi over 2 and pi over 2 because that would make the tangent undefined at negative pi over 2 and pi over 2. So it works a lot like the restrictions for the sine, except it's non-inclusive. It's exclusive of the endpoints. Okay, so again, we're going to put the ratio in and get the angle out. Let's do some calculations. All right, so we have remember the inverse tangent, again, is going to be thought of as an angle, and this time that angle will always be between negative pi over 2 and pi over 2, exclusive of those values. So that means we're going to be in the fourth and first quadrants again. So find the inverse tan of 1. So that ratio 1 is positive, so that means we're going to be in the first quadrant. So that's going to be pi over 4, that's 45 degrees. All right, example 10. Find the arc tangent. Again, same thing as inverse tangent, just a different way of writing it. So find the arc tangent of negative square root of 3 over 3. So that's negative, so that means we know we're in the fourth quadrant this time. All right, and that's going to be negative pi over 6. Okay, and with all of these, drawing a picture probably would be helpful with most of these. All right, so what about the tangent of the inverse tangent of negative 1? So start with the inverse tangent of -1, the innermost thing. The inverse tangent of -1, that ratio is negative. That means we're in the fourth quadrant. That sounds like it's going to be negative pi over 4. And then what is the tangent of negative pi over 4? Well, that's just -1. Okay. All right, let's try this one. The inverse tangent of the tangent of 4 pi over 3. Remember, 4 pi over 3 is in the second quadrant. So what is the tangent of 4 pi over 3? Remember, the tangent is the y over the x. So that would be square root of 3. But it's negative because it's in the second quadrant, because 4 pi over 3 is, no, 4 pi over 3 is, no, sorry, that's in the third quadrant, right? 1, 2, 3, yeah, 4 pi over 3 is in the third quadrant. So that is going to be positive. And so as a result, that would be just square root of 3. So we're looking for the inverse tangent of square root of 3. But that takes us back to the first quadrant, because remember, we can't be giving an angle in the third quadrant for inverse tangent. So we're back into the first quadrant because the ratio square root of 3 was positive. All right, so let's practice some more composition of these things. So what is the cosine of the inverse tangent of 5/12? Probably help to draw a little picture here, draw a triangle. So the inverse tangent, that ratio 5/12 is positive. So therefore I know I'm in the first quadrant, not the fourth quadrant. So that's where I drew the triangle. And we use Pythagorean theorem, and I can see my R is 13. So my cosine of that angle, so like I'm not going to find the actual value of that angle. So I don't know what tangent, the inverse tangent of 5/12 is. There's no way to find that angle, not as an exact value anyway. So we're looking simply for the cosine of that unknown angle, but fortunately we know the cosine of that angle is simply the x over the r, and so we have the drawing there, and we just know that that's 12/13. Okay, so we won't ever really know what that red angle is, theta, but we don't need to, because we're not asking you to find the inverse tangent of 5/12. We couldn't actually find that, but we could find the cosine of that inverse tangent of 5/12. All right, and let's look at 14. We're looking for the cotangent of the inverse sine of -1/3. So again, drawing a picture would be good. All right, which quadrant are we in? So the ratio, the inverse sine ratio that we're putting in is -1/3. So that means we are in the fourth quadrant. And we simply draw a triangle. Sine is y over r. So we have -1/3. And so we draw that. And we use Pythagorean theorem to find our 2 square roots of 2. That is not one of our special right triangles. So there's no way to find what theta is. But we don't really need to know what theta is, because we're not asking you to find the inverse sine of -1/3. We're asking you to find the cotangent of the inverse sine of -1/3. So we don't really need to find that angle, because we know what the cotangent of that angle is. Okay. All right. And I believe this is the last problem, number 15. We're looking for the sine of the arctangent of -1/√3 minus the arc cosine of 1/2. So you want to draw a picture for each one of these inverse trig functions. So the first one we'll draw over here, and it is negative, and it's an inverse tangent, so I know I'm in the fourth quadrant. And this ends up being one of our special angles, so we can actually put that value in there. So we're looking for ultimately the sine of -pi/6. And now let's concentrate on the inverse cosine. So we draw that. That's going to be in the first quadrant, because cosine, inverse cosine always gives us angles in the first and second, and it's positive, so we're in the first. And again, this is one of our special angles, triangles as well, so we can find the actual theta in these cases. And so that's going to be -pi/3. And so now we're just going to combine those. So -pi/6 minus pi/3 is -pi/2. And we're looking to find the sine of negative pi over 2. And that is simply negative 1. All right, so that takes us